So yeah, this topic will be about how to query your AiDA database. So yesterday you have been told how to launch a great number of calculations using AiDA, and you have also been told how AiDA tracks the provenance of your resulting data. And this is very nice and good, but it's fairly useless if then you're moving to the analysis part. So you need a way to get to the results and do some meaningful analysis of them. So this will be why you should pay attention now, why you should be able to query your database, and mainly the tools that we provide you to do that. So I'll just give you an illustration of what we're talking about. Imagine an AiDA user. He has done a lot of calculations, and now months later or whatever, they're finished, and now he wants to get to the results. So he would ask AiDA something like, I want maybe all structures that that have a certain property, for example, that they have more than 49 atoms. And he did MD on them, and the MD has resulted in a trajectory that spans this many time steps. So this is a fairly complex query, and at the end of the tutorial you should be able to do these things. But first we need to cover some background. So a query is defined as an operation that retrieves data from a database. And the operations that are necessary for you to do this are many, but we only cover 3 of them. These are how to project data, how to select a relation, and how to do joins on different relations. There's many more which we will not cover. And queries usually involve sequences of these operations. So you do projections, selections, and joins in sequence. Projections are defined as showing you certain properties of all rows in a given relation. So I'll just give you an example. Let's say you have persons. And a person is a relation that has certain properties. So the person has a name and an address and maybe a favorite hobby. So if you're only interested in the name of the hobby, that's what we talk of a projection. So you limit the number of columns in this table representation. So you only get the properties that you actually want. This is what a projection is, okay? It's important to remember this. Selections, restrictions are basically filters. So they tell you how to restrict the whole set of data that your database contains, or that the relation contains, to a meaningful subset. And the meaningful subset is chosen as such that it satisfies the selection criterion. So basically a filter. So let's say you're going on a hike and you have your relation person, and now you want only those persons that like hiking, so whose favorite hobby is hiking. So this would be a selection criterion. We select for all persons that like hiking, and then we project their name and their hobby. So it's important to understand what this really is. It's a filter on your relation. So you need to be able to apply filters by the end of the day. Joins are probably the hardest one to explain. They are formally described as a cross product between 2 relations that satisfy what we call joint predicates. So you can think of it as a meaningful combination of 2 different tables or 2 different relations. So if we do something which is very meaningful to do, we separate the relations person and hobby into 2 different relations. A person has still a name, and a person has an address, and a hobby has a certain label, and we might associate other properties to it, such as the danger level or anything else. And now if you want to find out which person has which hobby, you need to do a join on them. And so we want to say that we join person and hobby given that the person has this hobby. So how exactly this person has hobbies implemented, this is an implementation detail. In a relational database, this is given by an association table if it's a many-to-many relationship, so you would need to go via an association table. In a graph database, this would be an edge, the existence of an hobby edge between a person and a hobby. So this is implementation detail, but we need to know that we need to do these joins. You need to understand that sometimes these joins are necessary. The predicates, that's what AiDA takes care of. So you need just to tell AiDA what to join. Yeah? So if you want to apply these operators in AiDA, you basically are talking about doing graph-traversal queries, and we have provided you with this new functionality called the QueryBuilder class, which does that for you. So it does projections, it does selections or filters, as we call them, It joins to an arbitrary level, so you can do infinitely many joins, one after the other. It's backend independent, so whatever backend you're using in the background, the query should have the same format. And since it's implemented by us, we try to keep an eye on performance. And there's certain ways to do it. This is just a summary, so by the end you will have to do this in the exercises. I'm just summarizing what you can do here, and you will see a lot of examples on how this is being achieved. So you can project on any what we call column property, on states, on the attributes and the extras of a node. You will have, and you will learn how to use filters. So we've implemented a few very common filters to do your selections properly. And we've implemented joins, the joins that you see here. So you can join inputs to outputs, you can traverse via the transitive closure table, you can use computers, users, and groups. So basically any class that you find inside the AiiDA ORM, you can join together and do selections and projections on all of these classes. So this will be just a summary of what's being covered in the exercise later. I will just briefly give you very few slides of source code just to get an idea of what you will be doing, what you will be writing, what it will be look like. So it's a class, you will import it, you will make an object, you will instantiate an instance of this QueryBuilder class, so a QueryBuilder object, and then you will start appending to its path the entities that you want to join, that you want to query for. So this, for example, will now query for job calculations. And the results, you basically now execute the query by calling for the dictionary of the results. And you can loop over them to see. Projections are done with the keyword project. So you basically just list what you need for this special entity. A star means you want the ORM instance. In this case here, you're asking for the UUID, the creation time, and all the state, and the state of the job calculations in your database. You can apply filters. So this one filters, for example, for a calculation label, so that the label of a job calculation is the string, a calculation label. This filters for all calculations that have been created after the 1st of May. And this filters for all calculations that have been created between May 1st and June 1st. So you will see these queries in the exercises as well. So the important part to notice here, the keyword is filters. The keyword for projections is project. To join, what you need to do, and that's the only thing that you need to do, is basically just tell the query builder with a special keyword how to join. And then the join predicate and all the implementation details are done in the background. So you just say what the relationship of one entity is with another. It can be an input of another relationship. It can be an output of something. It can be a descendant and an ancestor. And you will see what each relationship exactly means in the exercise. So if you've seen this example, this is basically the AiiDA graph that you've seen maybe in some prospects or on the website. So if you want to query the whole thing, so you want to basically traverse the AiiDA graph, you will do this by picking a random point. It's up to you. For example, here we start at the top. So we start with structured data, and then you say that the SEF calculation, which is a PW calculation, is an output of this structured data, meaning that there's a link from structure to the output, to the PW calculation. And you do this by specifying that it's an output of. So this is the keyword that you need to provide, and this is the only thing that you need to do correctly. Then we go on and we say that, okay, there's results. It's an output of the SEF calculation, and there's parameters, which is an input of the calculation. So you go on and on and on until you have traversed every entity that you care about in a meaningful way. So the AiiDA users query that I presented is doable in this format. So it's a bit more complex because now you join, you filter, and you project certain things. So it's a complex query, but we see here that for every append method is basically you adding another relationship to your path. And on each one you will apply the filters special to this relationship, and you will apply the projections that are special to this relation. Yeah. And in the background, this is something that you don't need to care about. So this is done with SQL Alchemy. and with a Postgres dialect. So this compiles to this kind of query in the database. So just to give you an idea what's happening in the background, you don't need to worry about this, but this is what's being executed if you ask for the results. But what you see is basically a dictionary of results in the end, and you will see in the exercises how exactly this looks like, depending on your queries.